I want to say these first things should look familiar to people. Is that true? Like commutative property, associative property, we did some of that last year. So I'll try to go real fast and not talk too much lest I bore you. But I looked at this. So commutative property, well, one, it works for addition and multiplication, not subtraction, not division. Order matters with subtraction and division. But basically it's trying to say when you're adding numbers or multiplying numbers, order doesn't matter. 2 plus 3 is the same as 3 plus 2. 2 times 3 is the same as 3 times 2. Good? In geometry class, they'll have like for all real numbers a and b, then they say a plus b equals b plus a, or a times b equals b times a, and so on. Just basically adding, multiplying, order doesn't matter. I looked at it for keeping it straight as though commutative is kind of like communication. You know, if I talk to one of you, then they talk back to me. So it's kind of like A to B and then B to A, communication. Okay, ready to go to number 2? So associative property is kind of like changing who you associate with. If you look at it like you have 3 groups of people. But again, it's or 3 people. It's like addition and multiplication. It doesn't matter what you do first. So if I have this 2 plus 3 plus 4, I could do 2 plus 3 first and then add 4 to that. Or I could add my 3 plus 4 first and then add 2 to it. Good? So the same thing's true for multiplication. You could write it out with just all letters. So for all real numbers, A, B, and C, here's like the rule for the associative property of addition. Here's the rule for associative property of multiplication. But I started to say, you know, it's like who you associate with. I kind of picture like 3 people. Here, the first 2 people are hanging out, and person C is kind of on the outside. And now B and C are hanging out, and A is kind of excluded. So it's changing who you associate with. For me, that was just, I always struggled with remembering these things in geometry class. I was trying to come up with ways that I could remember it. So here's the short version of the truth. In problems with all multiplication or all autocorrect, this should be addition, didn't catch that, you can, 1, switch the order of the numbers. You can switch the order of the numbers. Or number 2, switch the order you combine them in.
Bless you.
I think the blessing was before the sneeze even.
Yeah,
that was like a...
Well, she said, uh-oh.
Oh, really?
Said, bless you.
You're on the ball. Okay, so for these, like 4 times 9 times 25, kind of how does this come in handy sometimes for real life? If you're trying to do this without a calculator, that's going to be kind of tough in some ways, but do you see how you could combine those numbers to make it a whole lot easier? So 25 times 4, so if we're kind of switching the order here, 9 times 4 times 25, and so all multiplication, you can change the order, and you can change how they combine them in. 4 times 25 is just 100, so really this is 9 times 100, or 900. And for me, I think that's a whole lot easier than saying, okay, this is 36. Now I need to do 36 times 25. I mean, you can do it. 4 25s get you to 100, so divide 36 by 4, you get 9, so it'd be 9 of the... I mean, you could do it, but it's just kind of ugly, if that even made any sense. Okay, the second one here on the right, you could do the 25 plus 75 gives you 100, so 25 plus 75 plus 48. Same as 100 plus 48. And there's other ways you can combine them. But basically, if it's all addition or all multiplication, you can kind of jostle things around and make it easier. We okay for those 2 properties? Now we've done our job. Geometry will be easy because you've had that. All right. Ready to go? Combining like terms. So if you have like terms, there's certain rules that apply for this letter A, addition, subtraction. There's different rules that apply for multiplication and division. That's why it's letter B. So in order to add or subtract terms, the variables must be exactly, I'm going to do that in all caps for dramatic emphasis. It must be exactly the same. In other words, when you have 4x plus 5x, this first one, can I combine those to get a certain number of x's?
Yeah.
Yep, 4x plus 5x is 9x. So you have 4 of the x's. You add 5 more of the x's to it. Now, the second one, you get x squareds if you're like multiplying kind of stuff. But for addition, you just say I have 4 of them, I have 5 more of them, you add them together. 5a plus 5c, this one here. Can we combine them?
No.
No, it'd be kind of like having 5 apples plus 5 carrots. You can't say you have 10 carpools or something. It just doesn't, carpools, whatever that would be. So for this one here, you can't combine. Or another way to look at it is this here, the 5a plus 5c. That's going to be your final answer. That is as simplified as you possibly could get. 4x plus 5. Can you combine that?
Nope.
No.
Nope. Because this one has an x for a variable. This one doesn't have any variable. So the variables aren't exactly the same. So final answer would just be 4x plus 5. Or you could say you can't combine. So adding, I didn't do any subtraction examples, but have to be exactly the same. Fair enough? The next part, the multiplication division, this is where you don't have to be nearly as careful about the variables being exactly the same. And if you struggle with this, it's going to come up a lot this year, so please don't move on to the next section before you get this mastered. But multiplication division, you can multiply and divide terms with different variables. So where if this first one was a plus, 4x plus 3, we couldn't do anything. But because it's multiplication, you could say 4x times 3 is, anyone? 12x. Pretty much for these, what you do is you combine the numbers, like you'll multiply the numbers, and then if it's just one variable, it just kind of follows along. The 6x times 2x. Luke, what's that going to be? Perfect, 12x squared. And what we're doing is you're doing, okay, 6 times 2 gets the 12, right? Mm-hmm. And x times x is the x squared. That this problem is really, 6x is really kind of like 6 times x. And 2x is really like 2 times x. Do you agree that's all multiplication? Mm-hmm. If it's all multiplication, what we just did on that first page was saying, well, you can change the order of the letters and numbers. You can change what order you combine them in. So you could say, since it's all multiplication, that's the same as 6 times 2 times x, which gives us the 12x squared. 8x divided by 4 becomes, nice, 2x. Because the 8 divided by 4 is 2, and then x, there's not another variable to combine it with, so it just kind of comes along for the ride. 9x divided by 3x. The number is going to be a...
Squared.
The number is just going to be a 3, right? 9 divided by 3 is 3. What's x divided by x going to be?
0.
They kind of, well, what's 4 over 4?
1.
1, right? They just kind of cancel each other out.
Mm-hmm.
So if we were to have an x divided by an x, they kind of cancel each other out, or it really just is like it equals 1. So you could look at it this way. You could say, okay, 9 divided by 3, that's going to be a 3. X divided by x is going to be a 1. 3 times 1 is 3. Or perhaps it might be nicer just to look at it as though, okay, the x's cancel each other out and they're just gone. But, any questions on multiplying and dividing? You're going to get a bunch of practice with this. And as we go through it the next couple sections, if you find you're struggling, let's go over it together because it's something that is really important for later on this year. Very last thing, distributive property. We've done it like last year, but it was mostly with numbers, which seems kind of dumb, quite honestly. A distributive property, you'll see this in geometry as well, for all real numbers A, B, and C, and then they'll give you this thing here. What essentially they're trying to say is if you have something with addition inside parentheses, or subtraction right there, and you have something times that, that thing in front that's multiplied has to apply to the B and to the C. It goes to both. So the A times B, that's where they come up with this. And then the A times the C is where they get the AC. Fair enough? So if we were to do 2 examples and then we are done. So here we do distributive right here, right? Now, a lot of people, it's tempting to just change that 5 plus 2 to a 7. But you agree you have to do this multiplication before you can do addition? So you can't add until you're done multiplying. So I just get that 5 plus. Now a positive 2 times a positive x becomes 2x. And now a positive 2 times a negative 7 becomes a negative 14. Does that negative make sense to people? I need to watch the signs. Now when we have 5 plus 2x minus 14. Who has a thought on that one? Final answer will be, or maybe I should talk through it better. Or
Negative 7x.
can I combine these two? Nope. Can I combine these two? But I can combine the positive 5, a little plus out here, and the negative 14. 5 minus 14 is negative 9. And that takes care of this and this. Do you agree I still have this plus 2x? But usually we write the variables first, so 2x minus 9. Thanks for sticking with me. We'll do the last one tomorrow. So this last example is really quite important because it has a little switch to it. And really the only difference is in front of the 2 we have a instead of a plus. But that minus there is what kind of hoses people. That when we take and do our distributive here, you have to look at that as though, or maybe I should say it's definitely easiest, or I'd say best, to look at it as though it's a negative 2 times x and a negative 2 times a negative 7. Where it's kind of like we have a little positive x right there. Make my pen a little bigger. So as we do that, we have our 5. Then when we do the negative 2 times a positive 1x, that gives me negative 2x. Nice. It's kind of like, I'm going to write it up here, a negative 2 times a positive 1x. Well, you do the negative 2 times the 1 to get the negative 2, and then it's kind of like 2 times 1. 1 times x gives you the x. So we have that. Now I'm going to do my negative 2 times my negative 7. That gives me a positive 14 now. And now the final step is to combine like terms. We can combine which two numbers? 5 and 14. So I'm going to say, all right, the 5, it's a positive 5. So you always look at the sign in front. And a positive 14 gives me positive 19. And I'm going to put the x in front. Standard way to do it, we haven't really talked about it, is to put the x's in front. So then I have a negative 2x. For now, I think you probably could get away with saying 19 minus 2x, but you're going to learn later that there, the negative 2x plus 19 is the normal, the standard, the right way to do it. So, any questions?